Okay, folks, these are the solutions to the balanced forces problems, and my memory is that just the problem descriptions are challenging. All right, so you may have to look at the beginning of the solutions. Okay, question 17. A bird on a wire. What is tricky about this one is they give you some distance measurements, and based on those distance measurements, you can figure out what theta is. Okay, so definition of tangent is opposite over adjacent. So this unknown theta is the arctangent of opposite over adjacent. So it's a teeny tiny angle, which is why we don't think it sags. Okay, I would give that to you, but this is a college level textbook. You know, in real life, you might have to do that calculation. All right, but let's do the real physics part of the problem together. Okay, so you have the bird on the wire. How much tension does the bird produce in the wire? Ignore the weight of the wire. So everything has weight. So the bird has weight, which is equal to mg, and the mass of the bird is 1 kilogram. So 1 times 9.8 means that force vector is 9.8 newtons. There are also, and so here's your telephone wire. What's the rule for tension? Tension pulls in. Tension pulls in. Okay, so we only care about this tension acting on the bird or under its feet. So I'm exaggerating it. This is a tension here and a tension here. By symmetry, unlike the example problem we did in class, by symmetry, these two tensions are the same. So we don't need a subscript. So these are both the same tensions. And then we just found out that that teeny tiny angle is 0.458. All right, and then the goofy mnemonic is, this is T cosine of theta, and this is T sine of theta. Same thing on the other side. T cosine theta, but it's negative, and T sine theta. Okay, so problem solving recipe is draw your force diagram, break down any vectors. Oh, sorry. Yeah, draw the force diagram. We did that. Break down any vectors. And then we're going to set up horizontal and vertical columns. Pretend like you didn't recognize that these two tensions were the same. So let's call this T1 and T2. Horizontally, the bird is not accelerating. So you're going to start with some of the forces equals 0, which tells you T2 cosine of 0.458 minus T1 cosine of 0.458 equals 0. The cosine of 0.458 is going to cancel. That just tells you that T1 equals T2. Oops. So bring that over to the other side. T2 equals T1. Okay, you don't have to prove that. By symmetry, you can see these two forces must be equal, so the tensions must be equal. Okay, but I just want to show you that's where that came from. So horizontally, these two forces are just canceling each other out. So what's important is vertical. Okay, so we're going to do the vertical column. And again, I like bringing in a highlighter and then recognizing I have 1, 2, 3 up and down components. We ignore crooked components. And so I'm going to have in my sum of the forces equals 0. I have 3 purple marks. I better have 3 forces. Okay. And then we've already agreed that tension is the same. So we have an upward force of T sine 30 on the left. We have an upward force of T sine 30 on the right. We have a downward force of the weight, which we've already calculated. Nobody's winning. The forces are balanced. Okay, and then we can just add these two together. So 2T sine 30 Bring that over to the other side, equals 9.8. So the tension is 9.8 divided by 2 times sine of 30, which is going to be huge, 613 newtons. Like, hopefully we did the goofy tug-of-war demo that proved that this tension has got to be huge because that angle is so shallow that in order for there to be an upward component of tension to balance the weight, the total hypotenuse overall tension has to be 613. Okay, so that was a lot of trig. Hopefully that worked out for you. Okay, this is question 19, and my memory of what people find challenging about 19 is just understanding what's going on because they're not familiar with boating. Like, so, if you're confused, you are not the only one. Okay, so we've got a sailboat moving north at a constant velocity. So constant velocity means acceleration is 0. We love that. Seen from a bird's eye view, basically. At this particular speed, the water is exerting drag. So the boat is moving this way, and it's literally running into air molecules, and that is causing drag of 220 newtons. So they told you that downward force is 220. I mean, downward from a bird's eye view. Because again, those molecules are running into the front of the boat. They just drew it down here so that you could see it clearly. Okay, choose X direction as east and the Y direction as north. Write 2 component equations representing Newton's second law. That's just saying horizontal and vertical component columns. Solve the equation for P, the force of, oops, looks like when I scan this, I did not scan the entire problem. So P is the force of the sail. That's this red thing, right? So the water molecules are causing 220 newtons of force. The air molecules are pushing on the sail. Let's call that pressure P, but we don't know it. And the rudder, I think what got cut off, the rudder is pushing this way, then they're calling it a normal force. So since we have 2 equations, horizontal and vertical, we can have 2 unknowns. So our 2 unknowns are P and N. But this is just like one of the hanging picture problems where here's the weight, here's tension 1, that's P, here's tension 2, that's the normal force. Okay, again, I'm sorry some of this got cut off. Not trying to be patronizing, I just want you to see that even though it's a boat, you're going to treat the problem the same as if it were a picture hanging. Okay, so that's everything that's going on. There's not enough room here, so I'm going to move to another slide. Okay, so this is our force diagram. The water molecules are 220 straight south. The rudder is this orange vector, which is totally horizontal. So the only crooked vector is vector P. And I crossed out the angle. That's 40 degrees. So that is making contact with this leg. So this is going to be P cosine of 40 and P sine of 40. Okay, so recipe is draw the forces. They drew the forces for you. Then break down any vectors. We only need to break down this vector. Be careful with your plus and minus signs. And then kind of optional, but let's highlight let's do horizontal forces because there's only 2 horizontal forces. And vertical forces. We have 1. Oh, so we have 2 up and down forces, the blue ones, and 2 left and right forces, the purple ones. We're going to be strategic and do the vertical first because you see you already know the 220 in the vertical. Worst case scenario, you guess wrong. That's why, just like the physics Sudoku, you don't know one box, just go to the other box. Okay, so we're going to do horizontal and vertical, but we're going to do vertical first. And since the boat was going at a constant speed, the sum of the forces are 0. And P sine 40 is up. And the 220 newtons of water molecules is down, and there's only 2 of them. Nobody's winning. So P sine 40 equals 220. The pressure from the wind is 220 over sine of 40, which is 342.3 newtons. Okay, that's the hypotenuse. Even though we were dealing with the vertical, right, that information, the hypotenuse information, went into our vertical calculation, so indirectly we found the hypotenuse. Awesome. So now that's our vertical column. Then we're going to do, let's do it in orange. Now we're going to deal, oh, no, pink, whatever, this is purple. Now we're going to say horizontally, and I can't see that. Sum of the forces adds to 0 as well. I have 2 pink forces. So I have P cosine of 40 pulling to the right. That was the wind. The wind was crooked. Minus the rudder, I think is what this is that I forgot to finish scanning. Nobody's winning there either because the boat isn't drifting left or right. We found the magnitude of the pressure from the vertical column. So 342.3 minus the normal equals 0. So the normal is, oh, my bad, 342.3 cosine of 40. I'm like, why is that? That can't be the same. I dropped the cosine 40. So the normal equals 342.3 cosine of 40. And sine and cosine are always 1 or less. So this is going to make the number smaller, to 62.2 newtons. So that's how much pressure this is, 262.2. All right. So hopefully that makes sense. We're going to keep practicing. Okay, this is most similar to the example that we did in class, and it is kind of a pain in the butt because this one is 2 equations, 2 unknowns, so I'll try to go through it slowly. Okay, so you have a bag of cement. You know the weight. So we're going to draw the forces on the knot. I'm going to draw it over here just so you can see it a little bit better. Okay. This one, I'm just going to talk you through it. This is a little bit tricky because if you look at this bag of cement, that weight is actually the weight of the cement. So if we just focus on the cement, then the weight of the cement is 325 newtons. If you just focus on the cement, the only rope touching the cement is T3. So since it's not moving, the T3 has to equal 325. Okay, so kind of transitive property then. This is why I make the big deal with the demo with the rubber band. T3 is pulling up on the cement and down on the knot. So the rope is supporting the cement, therefore the tension equals the weight. Now we can go over to the knot and focus on the knot. So this tension is 325. But I really, for reasons that will become clear, I think not until second semester, this really is tension. This knot doesn't know that the cement is pulling on it. It just knows that these rope molecules are stressed. So you don't have to go through this process of saying, I'm drawing the forces on the cement, these two are equal, and then go up to the knot. You can know that this tension is balancing the weight, and therefore that tension is 325, but don't call it weight, call it tension. Okay, so we know the lower tension. We are looking for T1, that's crooked, we're going to have to break it down. We are looking for T2, that's crooked, we're going to have to break that one down too. Okay, and then theta 1 is 60 by alternative interior angles. If that was 60, this is also 60. So this is T1 cos 60 and T1 sine 60. And then I tell you theta 2 is 25. So this is 25, and then I'm running out of space, sorry. And so the horizontal part of this green vector is that 325 is in the way, but I'll redraw it on the next page. That is T2 cos 25, and it's pulling up with whatever T2 is times the sine of 25. Okay, so we've got 3 ropes. Each of the tensions is pulling towards the center of the rope. Hopefully that makes sense. Okay, we don't care about the pull on the ceiling. We don't care about the pull on the ceiling. So ropes pull towards the center. We have 3 of them. We have to break down 2 of them. Okay, then super quickly, how many left and right forces do we have? 1, 2. How many up and down forces do we have? I'm going to go with pale blue. 1, 2, 3. Okay, so refer to your own diagram in your notes. Horizontally, the sum of the forces have to add to 0. And T2 cos 25 is positive because it's pulling to the right. So we have T2 cos 25 is positive, but T1 cos 60 is pulling to the left. And neither one is winning, so the forces are balanced. Okay, so I'm going to add that to both sides. And then I'm going to divide both sides by cos 25. And you get that T2 is T1 cos 60 over cos 25. All right, not a problem that we have 2 unknowns because we haven't used our vertical column yet. So vertically, the sum of the forces are 0. And we've got 2 upward forces. Okay, so even though horizontally the 2 ropes are competing against each other, vertically they're helping each other out. T2 sine 25 is up, T1 sine 60 is up, and the weight is, or sorry, it's not the weight, T3 is down. Okay, so we're going to have 3 terms here. We have T2 sine 25 up plus T1 sine 60 up minus 325 down equals 0 because we figured out the tension T3 was 325. Okay, now we're going to take this and plug it in for T2, leaving us with only 1 unknown. Okay, so we have T1 cos 60 over cos 25. All of that is T1 all of that is T2, but don't drop your sine 25 plus T sine 60, and then this is subtracting minus 325, so I'm going to add 325 to both sides, which is nice because then everything here is positive, everything there is positive. Okay, and this is a T1. Okay, so then this gives me T1 cos 60. I'm going to push these together. Tan 25, right? Sine over cosine plus T1 sine 60 equals 325. Okay, and then you could factor out the T1, or you can multiply all of these things on your calculator. It looks like I multiplied them, and just so people could follow along and find their mistakes. Sorry, this is 0.233 plus T1 times sine of 60 is 0.866 equals 325. And then adding those two things together gives you 1.10 T1 equals 325. Divide both sides by 1.1 gives you T1 equals 296 newtons. Right, because this is dividing by a little bit more than 1, so it reduces it a little bit. Almost done. So that's T1 in the home stretch. Plug that in, and T2 equals 296 cosine 60 over cos 25 equals 163 newtons. Okay. Not as many ways to check your work here. You can't add these two tensions and get the weight, because what we found was the hypotenuse and the hypotenuse, and this don't add to the weight because they add like vectors. So what you could do if you're not sure, again, you can check your work with the answers, but if you were taking this class in college and you wanted to check your work, you could plug in this is 296. I mean, you could do a couple of checks where you could say 296 cos 60, is that equal to 163 cos 25? Do you know what I'm saying? You could go back and make sure that your two tensions satisfied this equation and this equation. If you're someone, if you're someone who likes to check their work. You could absolutely do that. However, that only tells you that you have done all of your algebra right? If you've set up these equations wrong, this is not going to tell you to set up the equations wrong. But I hope you did set up the equations correctly. A couple people have already, this is in 2025, a couple of people have already reached out and said, hey, I'm struggling with the homework. So you are not alone. I promise you we're going to keep practicing this stuff. Even though we keep adding new forces, the procedure is going to continue to be the same. All right. So hopefully this video was helpful, and I will see you in class.